This presentation is about Silab Tech's low power SerDes IP subsystem. Okay. We'll be covering the corporate overview, our company details, and we'll cover the SerDes IP market, Silab Tech unique advantages, and we'll also go over the portfolio of SerDes IP that we are offering. Uh, we'll touch about the in-house expertise that our team has in designing the SerDes IPs, and then we'll cover the IP portfolio that we have, and we'll touch upon the summary at the end. So our company was founded by a team of designers with several years of experience at Texas Instruments primarily and other Tier 1 semiconductor companies such as ST, Ericsson, and Cypress. Uh, we are based out of India and we have design centers in Bangalore and Pune. As of now, we are focused on high-speed serial interface SerDes IPs, PLLs, and power management IPs. And we also do a few custom IOs, which lines with the serial interface connectivity IPs. And we have partnerships with digital controllers, which form the link layer of the SerDes IPs. And we are partnering with top fabs for our test chips. A lot of our SerDes IPs need to be characterized on silicon, and that requires a lab which is capable of doing that, the high-speed testing. And we have a lab which is equipped to do that and also run the compliance test for these IPs. So I'll just briefly touch upon what a SerDes is. A SerDes stands for a serializer, deserializer, and the transmit channel typically has a serializer followed by a de-emphasis block, which is basically added there to cancel the high frequency losses in the channel. On the receive side, we have an equalizer at the front end, followed by a CDR and a digital equalizer loop. That is followed by a deserializer, which gives the parallel data out to the digital. So the challenge here is mostly in designing the receive front end and mostly in the equalizer and the CDR design, where a lossy channels output, which would be a completely closed eye, has to be recovered and translated into digital data. There are lots of standards for various applications for serial interfaces. And some of the examples are USB 3.0, MIPI, SATA, PCI Express, and others. So one of the challenge here is to design one IP which would serve as many of these standards as possible and offer it as a combo PHY for the customers. So the customer licenses one IP from us and he can use it for multiple applications. So here's one example of how a serial interface standard had evolved and gone into many other application areas which were not intended to be the application areas at the start. So this is slightly old data about PCI Express, which initially started off as an interconnect mainly used inside PCs, but as time passed, it was used for many other applications such as embedded PCs and consumer electronics as well. And this graph here shows the complete interface IP market for the past and also the prediction for the future. And as you can see, since the past 3 or 4 years, the market has been growing rapidly, and you can see the several segments in which the growth areas have been in most of the commonly used serial interface IPs. So for an IP user or an SoC designer, there always is the question of either making the IP yourself or licensing it or buying it from an IP vendor. So what are the considerations involved for that? So the biggest consideration is the cost for development. These are complex IPs which require a lot of expertise in analog and mixed signal design. So you need that expertise and the cost for developing that. The other aspect of this decision is how reusable is the IP. An IP company can design it once and license it to many customers. Can you do that in house, and how much reuse is possible in house? Uh, the other aspect is also, of course, about the licensing cost and the royalty you pay to the IP vendor. Uh, and for silicon proving and having high confidence on these IPs, you of course need to have capability to test these IPs, and that requires a lot of lab infrastructure, expertise in PCB design for characterizing these IPs. So that is one more consideration involved in whether to make an IP or buy an off-shelf silicon proven IP. So Silab Tech has a lot of experience in not just designing these IPs, but integrating these IPs into end customer SOCs. And we have worked very closely with SOC teams in the past to solve their problems in integrating these IPs, characterizing these IPs on their chips, and also integrating them into their final customer products. And our IPs have the lowest area and power, uh, best in class area and power, and this is the feedback we have received directly from our customers, and we can provide the area and power numbers under NDA. And all our IP is designed in-house from scratch. There is no royalty or licensing to be done from any other third party. Our IPs are also supported by a large design services house, Secontech, which has experience in integrating these IPs into an SOC, and they provide the services for integrating these IPs into your SOC. We also support customization of our IP in case your use case slightly differs from the standard IP use case, in which case you might want small modifications around the IP, and we are flexible to provide that. And, and in case you have any questions or any trouble integrating the IP, you can reach you can reach the design team directly. There's no multiple levels through which your question goes, and it takes long time to get a response. A lot of these IPs are very complex and require a lot of care abouts at SOC level while integrating them. So this is a key aspect of how well your support team knows the IP itself. And our team has an experience of integrating these IPs into SOCs and designing them over several years. So typically the time taken to get to the end result is very less. Our design overheads are very less. So here you can see the IP subsystem portfolio for the SerDes and connectivity IPs. And so on the left there is the SerDes IP portfolio, and these are classified into two types. There's a 10 plus Gbps SerDes IP portfolio and a 6 plus Gbps SerDes IP portfolio. So 6 plus Gbps is where most of the commonly known connectivity IPs are present. So some examples of that is USB 3, PCI Express, the MIPI M5 Gear 1, 2, and 3. In the 10 plus Gbps SerDes are mostly the Ethernet standards, the OIF standards, and also the PCI Express Gen 3, which is 8 Gbps, falls into that category. We also support the lower data rate IPs, which are not the main focus but are required for completing a solution. For example, USB 2.0 is an IP which is required for completing a USB 3.0 solution. So we offer that IP. We also offer the MIPI D5 IPs, which are the camera and display interfaces. And we have a few selected I/O designs. These are not GPIOs or pad libraries, but these are specific special purpose IOs such as SDIOs or MMCIOs. And around the IP, there are IP-enabled services. Uh, so we also offer services to customize the IP to your need and integration of the IP. So by integration, it's more about the functional integration or RTL integration, and also the physical integration. Uh, these 10 plus Gbps SerDes macros are very sensitive to package and PCB parasitics. So there's a lot of help needed for the customer to integrate this IP and design packages and do the physical integration in a way that enables the performance of this IP to reach the maximum. And part of the services also include the annual maintenance contract. So here I'm showing our several aspects of our in-house expertise related to these IPs. Uh, Pre-silicon, we do a lot of simulations to have accurate prediction of the IP performance on silicon. And we do a lot of system level simulations where we need to predict the bit error ratios and the performance of the IP beforehand. So that requires accurate modeling of the channel, the package, and also the sub-blocks. So we have a full set of simulation models for these, and we verify a particular IP in that setup, and we accurately model all the aspects of it and then simulate it so that we have good confidence that what we are going to get on silicon is what we expect. Of course, once we have the IP back in the silicon form, we need to characterize it to make sure that it meets all the performance as expected. So we have an in-house lab which is capable of characterizing that. This characterization setup typically involves a very high bandwidth analog oscilloscope or a digital sampling oscilloscope. And of course, then for the receive testing, you need the bit error ratio tester, which sources high-speed data and compares the data received by the PHY. And for the jitter characterization and the PLL characterization, we need the spectrum analyzer. So we have those equipments in place to make sure that the silicon is performing as expected and as designed. And the other aspect of silicon proving these IPs is to design boards and have a validation setup which is representative of the final setup. So we design boards which would take in the silicon, and we can characterize at various points along the link. So we can characterize it. We can characterize the performance of the SerDes at the edge of the board, or after a channel, followed by another PCB. And then there is the aspect of integrating this IP with a digital controller, which basically forms the link layer of the protocol. So in that case, what we do is we have the protocol logic on an FPGA, and this would typically be the controller supplied by one of our controller partners. And our PHY, which is the hard macro, would be on our test chip. And then we have these two interfacing between the two PCBs, and this entire system is validated for interoperability with another link. So let's say in the case of USB 3.0, this would be a setup where we plug in the USB cable to the other end of the PHY, and the cable is plugged into a PC, and we would show a data transfer and a throughput demo. So this slide shows the ecosystem around our IPs. At the productization level, we have partnerships with foundries, test houses, packaging houses, and assembly houses. So this is what it takes to get the IP in the silicon form back. And as far as integration of the IP into an SoC goes, we have partnered in the form of Secontech, who are involved mostly in chip level DV, chip level DFT and physical design, embedded hardware and software, and validation. And then comes the IP subsystem, where you have the actual IP from Silab Tech and the digital controller, which comes from our controller partners. So, yeah, just to summarize what we just discussed, uh, we form an IP subsystem with the lowest area and power numbers. And our offering does not just end at the IP itself. We have a whole range of services around the IP, which enable smooth integration of the IP into an SoC, or a smooth bring up of the SoC itself, which contains the IP. The support comes from the team which is directly involved with the design itself and is completely well versed with the design. So the support is quick. And our controller partners deliver the link portion of the PHY, and we provide a complete proven solution for the entire subsystem. We have flexible licensing models, and you can get in touch with us about the various licensing models that we offer for our IP.